Hi everyone. Today we're going to be talking about the idea of what happens if a parabola has 1, 0, or how can you even identify when a parabola has just that one x-intercept. So when converting from standard form to factored form, you may factor the function and find the same zeros. Remember, this word means the same as x-intercept. This means the parabola has only 1, 0. So let's say hypothetically I'm trying to factor this function right here, x squared plus 8x plus 16. We've got a equals 1, b equals 8, and c equals 16. So if I use the diamond method, I have 16 up here and 8 down here. So I'm trying to find two numbers that multiply to 16 but add to 8. So those numbers are actually positive 4 and positive 4. So that means x plus 4 multiplied by x plus 4 is the same factored function. You can actually rewrite this as x plus 4 to the second power because it's just multiplied twice. So this means, because I only have the positive 4 as a factor, that when I solve it out, x plus 4 equals 0, for the x-intercepts, I'm only going to find one x-intercept. Both of these are going to give me x equal to negative 4. So that means the parabola only hits the x-intercept once. Let's look at this problem over here. X squared plus 8x plus 12. A equals 1, b equals 8, and c equals 12. So now I'm trying to find two numbers that multiply to 12 but add to 8. Those two numbers would be actually 6 and 2. So that means if I factored this out, I have x plus 6 and x plus 2. So this means this would give me two different zeros, two zeros, and this right here would only give me 1, 0. Okay? So let's move forward and see what this looks like in the examples. Okay, so in the first example, again, I've got a, b, and c. I want to label those and factor my function. A is equal to 1, b is equal to negative 4, and c is equal to positive 2. So if I use my diamond, I'm going to find, c is positive 4. I'm going to find two numbers that multiply to positive 4 but add to negative 4. Think about the factors of 4. I've got 2 and 2 and 4 and 1. I know that 2 and 2 would multiply to 4, but if I need them to add to negative 4, I actually need to both be negative. So I write my factored form, f of x equals x minus 2 multiplied by x minus 2. Oh, since the factors are the same, I can write it as f of x equal to x minus 2 to the second power. Okay, so now I've only got one factor, really. The two factors are the same. So I write x minus 2 equals 0 to be able to solve for my x-intercept. So I add 2, so I get x is equal to positive 2. So my only x-intercept is actually 2, 0. Okay, in terms of y-intercept, I look at c. So that's 0, 4. And my vertex, that will require me to sketch my graph a little bit. So let's see what we've got so far. X and y axis. We've got 2, 0, 1, 2. That right here is 2, 0. Let me rewrite this. 2, 0. Up here, 1, 2, 3, 4. That's my y-intercept. 0, 4. Okay, so if this is actually my only x-intercept, that means that it must be my vertex. Okay, so since it's my vertex, I also know the axis of symmetry is x equals 2. So if you want to pause here, think about this. Again, if you only have one x-intercept, that means it either hits and goes back up or it hits and goes back down. Because that's the only way. Otherwise, you're crossing twice, or you're crossing twice, or you cross never. Okay? So, now that I know where my axis of symmetry is, that means if I'm 2 away with my y-intercept here, I can actually be 2 away on the other side. 1, 2. So again, if this is 1, 2, so now I want 2 more spaces, so 3, 4. I'm at x equals 4. And I know since the axis of symmetry, that means that I'm going to be at this height as well. So 4, 4 is another helpful point when drawing my parabola. Okay? Alright, let's move on to the next example. Example 2. So I see g of x is equal to negative 2x squared minus 12x minus 18. Something goes off in my brain. I know that 2, 12, and 18 all have the same factors, or they have at least one similar factor, which is negative 2. So this is, I could actually divide out a negative 2 first to be able to start factoring. So I've got g of x is equal to negative 2. Negative 2 divided by negative 2 makes 1x squared. Negative 12 divided by negative 2 makes positive 6x. And negative 18 divided by negative 2 makes a positive 9. So now I want to use that a, b, and c value. We've got a equals 1, b equals 6, and c equals 9. So I've got 9 up here, 6 down here. Two numbers that multiply to 9 but add to 6, positive 3 and positive 3. Because 9 has 1 and 9 as a factor, or 3 and 3. 1 and 9 would add to 10, and I'm looking for 6. Okay, so now I've got g of x equals negative 2 multiplied by x plus 3 multiplied by another x plus 3. That's an x right here. So I notice that the factors are the same, meaning that I could just write it as x plus 3 to the second power, or squared. Okay? So now I've got x plus 3 equals 0 to find my x-intercepts. So I subtract 3, so x is equal to negative 3. Since both of the factors are the same, I know I'm just going to get negative 3, 0 twice, meaning that this doesn't exist. Okay? So here's a different way that you can explain the axis of symmetry. So negative 1, negative 2, and negative 3. Here's negative 3, 0. Usually, we try to find the halfway point. If there is only one point, the halfway point must be that point. So x equals negative 3 is the axis of symmetry. I didn't do the y-intercept yet. I looked back to my original c, so that's 0, negative 18. Okay. 0, negative 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I'm going to bring down my axis of symmetry. Actually, I'm going to redraw this graph. I didn't realize it was going to go down so far. So negative 18, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This is 0, negative 18. negative 3, 0. That's my x-intercept. 1, 2, 3. That's also my axis of symmetry. Okay, so now I want to find the distance. This y-intercept is 3 spaces away from my x-intercept. It's also 3 spaces away, more importantly, from my axis of symmetry. So that means if that's half of my parabola, I want to go 3 spaces over on this side, 1, 2, 3, but at the same level. So negative 3, negative 4, negative 5, negative 6. So my x value is negative 6 on this other point, and then it's on the same y value of negative 18. So that means that I've got this point, and this point as points in my parabola. So my vertex again is the same as the x-intercept because I've only have one of them. And another helpful point that helped me plot this parabola was negative 6, comma negative 18. Okay? And for the final example, this would be a good time to pause the video and try it on your own. And here's the third example. I've got h of x is equal to x squared minus 10x plus 25. I don't have any common factors here. My a is just 1, my b is negative 10, and my c is 25. So I draw my diamond. I've got 25 at the top, negative 10 at the bottom. 25, the factors of 25 are 1 and 25, and 5 and 5. So 1 and 25 would make 26, 5 and 5 do make 10, so I know this is going to be a 5 and a 5. But if I need it to be negative 10, I need both of the 5s to be negative. So I'm going to rewrite h of x equals x minus 5 multiplied by x minus 5, which is the same as h of x is equal to x minus 5 to the second power. So if that's the case, to find one of the x-intercepts, we've got x minus 5 equals 0. I add 5. Both sides of the equation, so I end up with x equals 5 as my only x-intercept. So 5, comma 0. My y-intercept, I look back to the original c, that's 0, comma 25. So I know that this parabola is going to go up high. So let's draw that out. One, two, three, four, 5. That's my x-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. That's my y-intercept, 0, comma 25. Okay. So now, since this is my only x-intercept, I know that my halfway point, which is usually my axis of symmetry, is actually just wherever that x-intercept is. X equals 5. So that's my axis of symmetry. And I know if I substituted in 5, I'm going to get 0, just by definition of the x-intercept. So that means I just need to find some extra helpful points. So again, if this is my axis of symmetry and this is halfway, if this is 5, and that's half, I need another 5. So another 5, 6, 7, 8, 9, 10 would get me to an x value of 10. I need to go up to, I need to reflect the y-intercept. So if this is 5 away, and this is 5 away, then I'm now at 10, comma 25. So then this point right here, this point right here, and this point right here are all part of my parabola. Okay, and that's the video for today. Thank you.